Hello to everybody. My name is Victor Palomino-Tapia and I'm working with Poultry Health Services as a research scientist. Today, I want to talk about Avian Reovirus in the context of Canadian production and how it has truly become a pain in the leg. The presentation has been divided according to this outline. We will talk about some general aspects of the disease, different manifestations of the viral infection, transmission, diagnosis, control, steps on autogenous vaccine design, and take-home messages. As you all know, avian reoviruses are enteric, non-enveloped naked viruses, which are quite resistant in the environment and capable of sustaining heat and to remain infectious in barn materials for long periods of time, indicating that cleaning and disinfection is paramount. Viruses are also present in every commercial poultry farm in the world. Now you can say, hey, wait a minute, how come disease caused by reovirus is not everywhere then? And the reason for that is that most of these viruses will not cause disease. Actually, many are found or can be found in healthy birds. This means that seroconversion in ELISA or even virus neutralization does not equal disease. Exposure does not mean disease. The most important viral protein is one called sigma C. This protein is responsible for cell attachment and stimulates the immune system to produce protective antibodies. Here in the image, you can see a 3D representation of this virus, these virions, and this gray protein right here is the sigma C protein. The first vaccine was approved in the 80s and is what we call a classic strain. Those viruses are different from the classical strains, which we call variants. Now, these variants are causing arthritis and other issues in chickens and turkeys since 2011. Classic vaccines only protect against classic challenge, that is the cluster 1 viruses. Now, these classic challenge viruses are still circulating and we need to protect against those as well. Variant viruses, reovirus, need to be monitored in order to tailor our control strategies. Each time a farmer has a reovirus problem and samples are sent for virus isolation, this new Canadian isolate is sequenced, genotyped, and grouped into one of 7 clusters here. This phylogenetic tree was produced as part of a PhD project in association with the University of Calgary and the Institute for Applied Poultry Technologies. Now, this phylogenetic tree contains more than 180 isolates across North America, and for now, the most important clusters for the poultry industry are the cluster 5 here and cluster 4. Now you can see that there are challenge viruses, Canadian challenge viruses marked in bold here, from cluster 1, cluster 2 here, cluster 3, cluster 4, cluster 5, cluster 6, and a novel cluster 7. New disease presentations and molecular studies have motivated researchers to reclassify reoviruses in chicken reovirus and turkey reovirus. So within the turkey reoviruses, even further classification has occurred. And now we are talking about turkey arthritis reovirus, turkey enteric reovirus, and turkey hepatitis reovirus. Now, the infection has been associated with multiple clinical manifestations in chicken and turkeys, such as viral arthritis, ranting and stunting syndrome in chickens, poult enteritis in turkeys, and turkey reovirus hepatitis. We will talk about the disease, these infections by reoviruses caused in chicken and turkeys. One of the most important manifestations of the disease is that of viral arthritis and tenosynovitis. We see this mainly in meat-type birds and more in broilers rather than in breeders. This presentation is different from the original cases observed in the 70s and 80s, in which the disease was mainly seen in broiler breeders. Now it is more observed in broilers. The disease susceptibility is age-dependent. So the infection occurs early in life through a vertical and horizontal route with clinical signs showing a later age. So these clinical signs consist of lameness, rupture of tendons, increased secondary infections, which lead to cooling, use of antibiotics, and condemnations at processing plants. Chickens break usually between 4 to 5 weeks, but they can break as early as 6 days. The cool rates range from 2% to 50%. And in severe cases, the population has been done. Some of the rule-outs to have in mind of this particular condition are secondary bacterial infection, like Staphylococcus, for instance, fluorosis, foot pad dermatitis, osteomyelitis, and Mycoplasma synovitis. Ranting and stunting is a manifestation of RIO that is usually overlooked and affects mainly broilers, but also layers. It is interesting to note that some viral arthritis viruses will also have some phenotype of ranting and stunting. The infection as well occurs early in life through vertical horizontal transmission, and the producer can observe diarrhea that can be orange, usually between 8 to 10 days of age, due to the viral replication in intestines. This impairs the ability of the intestine to absorb nutrients, resulting in malabsorption syndrome. Many of the clinical signs of this particular syndrome are a direct result of the nutritional deficiencies the bird has due to this impaired gut. Uniformity issues are obvious by the second week of age, and here we usually observe pale birds, growth retardation, abnormal feathering, and/or femoral head fractures with pancreatitis. There are other agents implicated in this syndrome, like, for instance, astroviruses. Here we observe a bird from one of our trials with RSS manifestation. This bird is depressed, retarded in growth, and has poor feathering. Malabsorption caused by reovirus and other viruses as well may cause other problems such as rickets and vitamin deficiencies. Toms. Here in the photo, we can clearly see the level of inflammation in the left leg of this bird. The susceptibility is age-dependent and infection occurs early in life. However, clinical signs are observed at a later age, around week 13 and onwards. With lameness, which can affect up to 70% of the flock, excessive cooling, and interestingly linked to high aortic rupture before processing. Here we observe a photo with hemorrhage around the aorta in a turkey with aortic ruptures, and here we observe another turkey aortic rupture with a pale carcass and blood in the abdominal cavity. Many cases are found with concurrent bacterial infection, and the main rule-outs for this condition would be primary bacterial arthritis, muscle rupture, osteomyelitis, foot pad dermatitis, synovitis caused by mycoplasmas. presentation in turkeys is that of reoviral hepatitis. This has recently described in the 2020 AAAP, and now we know that there are more than 90 outbreaks in the US since December 2018. This manifestation occurs in 10 to 25 day-old poults with a sharp increase in mortality. This mortality has congested greenish liver, and you can observe neurological signs in some subset of the population. Now, interestingly, you can observe also viral arthritis in the same flock when it reaches around week 15 onwards. Some of these cases have been reported with association with turkey viral hepatitis, which we still don't know what role is playing. Rule-outs for this condition will be turkey viral hepatitis, bacterial hepatitis, etc. Finally, we got poult enteritis, which can be considered the turkey version of the Ranting-Stanton syndrome in chickens. And together with astrovirus and rotaviruses, they form part of the poult enteritis complex of poult enteritis syndrome. What you can observe here is that you have diarrhea with paste events, distension of the small intestine, and distended ceca, as here in the photo is shown. However, interestingly, many of these viruses cause several degrees of bursal atrophy depletion, which kind of make us think of immunosuppression. We observe growth retardation, uniformity issues, and high mortality. The growth retardation shown here in the photo, and difference in sizes with this control bird and this affected bird. Rule-outs are bacterial enteritis, turkey coronavirus, and other viral enteritis. Avian reovirus transmits vertically and horizontally. In the horizontal transmission, we observe that the entry can be to the respiratory tract, the intestinal tract due to fecal contamination, and through broken skin. In this particular situation, the virus enters the broken skin through contaminated litter contact with those tissues, and then the virus replicates locally and replicates then in the tendon and finds its way to the hook joint and viremia as well. We observe age-related resistance, which highlights the importance of maternal antibodies. We know that in order for the disease, the clinical disease to occur, birds need to be challenged within the first 2 weeks of life. The youngest, the most susceptible will be the bird for the virus. And also we observe vertical transmission. Here, the egg transmission is low and variable between the strains. Usually, the literature that you can read shows an infection rate of 1.7% on the progeny, 1.7% below, right? So, parent stock can be infected by oral respiratory skin inoculation and transmit the reovirus to the progeny. Now, you can find carrier birds, and these can act as a potential source of infection. The virus can persist in these birds for more than 250 days. The reovirus can be found in eggs up to 19 days post-infection, and contaminated feces may contaminate eggshells, which, because of the really hardy nature of this virus, can contaminate progeny as well. Just imagine you have contaminated eggshells in an environment, a hatchery, right? So they hatch and they will be breathing in perhaps feces contaminated with reovirus. Let's talk about diagnosis. Not all avian reoviruses are pathogenic, which means that the seroconversion doesn't actually mean disease. Now, for some avian reovirus clusters that are different, very different from the classical strains, the commercial ELISAs don't work well, which means that there are some instances in which you will run ELISAs and you would not be able to pick up the seroconversion of those variant reoviruses. A confirmed diagnosis of viral arthritis must consider all the following three. First, reference clinical signs of the disease. Rule out all possible causes for field clinical signs, which means that you have to do bacteriology, histopathology, and then finally identification of the reovirus in the tendon tissue by either PCR or isolation from joint tendon. So once the vet has checked on the first two, we can call it a suspect or tentative diagnosis. In histopath, this is something that we are looking for. These nodular developments of lymphocytes over hard epicardium, and also these lymphoid nodules in the synovial membranes. This is a cut on the tendon. The following lab report summarizes the findings of, in this particular case, on the histopathology, bacteriology, and molecular diagnosis, and even virology. So here we observe that in the case of bacteriology, for instance, liver, spleen, and heart were sampled in order to discard bacteremia. No bacteria was isolated in these samples. Just the avian reovirus was found on the tendon, and later on it was found in viral inoculation of tissue culture and egg inoculation. So this particular case can be considered a confirmed reovirus case by a vet. Let's talk about control now. There is no treatment for this disease. Viral arthritis is controlled by biosecurity, strong biosecurity, and cleaning and disinfection in between cycles will reduce the effects of the disease. This is because this is a naked virus, very, very resistant to the environment and to changes in temperature. Then another strategy is parent stock vaccination, which will reduce the disease incidence by first reducing the level of infection in the breeders, preventing egg transmission to the progeny, and producing protective maternal antibodies for the progeny. Now, what type of vaccines do we have? We have commercial live modified vaccines, we have commercial inactivated vaccines, and finally we have autogenous inactivated vaccines, which are meant to be produced only to control for this variant reovirus challenge. About the licensed vaccines, here we have a chart of all the different fully licensed strains that we can apply to our birds. We have two different strains for live vaccines associated with viral arthritis, and a bunch of others associated with Ranting-Stanton syndrome, viral arthritis, femoral heat necrosis, and proventriculitis, part of killed products. None of these licensed vaccines will protect against a variant challenge. None. You will need an autogenous vaccine for that. And so what can we do, right, in order to protect ourselves from viral arthritis? We need biosecurity, we need breeder vaccination with proper vaccines, and we need to monitor. What's the challenge? Let's talk about autogenous vaccines. Autogenous vaccines are emergency vaccines that are meant only to be used when a problem cannot be solved by fully licensed vaccines. There are no live autogenous vaccines. Thus, there is no live priming, which means that the first vaccine that the immune system sees. Whatever you see first will define how you see things after, and that's something that is relevant for the immune system as well. The duration of immunity, because of that, it's limited. When you try to build immunity only in activated vaccines, you don't have as good as immunity as if you had a live vaccine as well. That's the reason in high challenge areas in the United States, they sometimes add 1 to 2 vaccines in the laying period, between 2 or at 2 and 8 weeks of lay. The good news is that you have certain flexibility on what isolates to include in an autogenous vaccine program. The bad news is that they are only valid for only 24 months. So the question, what to include in this vaccine, is very important. It's very important to get it right, that the right isolates go into that vaccine. And we will see why in a minute. This is an schematics of what the autogenous vaccine design flow looks like, all right? So first we start with the first bird infected with variant Rio, a flock that has the first bird infected. You have the first clinical signs after 1 to 7 weeks. You have all the flocks suspected of Rio in 6 weeks' time. They are popping around, they are appearing, and you are observing them and everything. Now, you identify that there are some farms that are more suitable for virus isolation and typing. You submit that and you receive the report from the laboratory. The laboratory have isolated those viruses after 2-3 passages in eggs and tissue culture. Then they do the molecular analysis. They compare it against all the different viruses that you saw. And they tell you, is this type of virus? Oh, okay. So you have the answer for this particular case. Now you have to check another case and you kind of start building an idea on how the challenge looks like in that particular area or operation, right? Now you have to take a decision what to include in the vaccine. Okay, so I have class 4, class 5, I have this weird class 2, should I include it or not, right? Always having in mind that every isolate you include in that particular vaccine will have a cost in the vaccine, and it also will, there is so much space you have in these particular autogenous vaccines to put, antigens, to put viruses. Once you have decided that, you need to prepare the paperwork for local, Canadian, and also US governments if you are planning to prepare your vaccine back in US, right? You have to wait for the vaccine to be produced between 20 to 30 weeks. And sometimes there are going to be other producers that have kind of more clout than you because they are in the same country or they have a contract before. So the thing is that it can take up to 30 weeks. After the vaccine is prepared, the vaccine needs to be shipped, needs to be transported. That can also take time, can take between 2 to 4 weeks. From the vaccine, from the moment the vaccine is produced up to the vaccine is placed in the chest of the first broiler breeder flock at 18 weeks of age. After that, the first chick is placed from this first vaccinated flock. There are 10 weeks because you need to wait for the bird to reach production, to start laying, and then the egg to hatch, right? So 3 weeks more. So time from the first infected bird with variant Rio to the first bird placed with maternal antibodies against that Rio, 77 weeks in Canada, this. So it can take up to 2 years from the first bird infected with variant Rio until the autogenous vaccine is implemented in 100% of the system. Up to 2 years, between 1.5, 1 year and a half, and 2 years. That's the amount of time it takes in order to fully implement whatever isolates you choose at a particular moment. That's the reason it is essential to get the right Rios for this autogenous vaccine program. Now, the take-home message is we have representatives of all 7 clusters circulating in Canada. Most sequences are from cluster 4 and 5, but this may change in the future. Reovirus is endemic in Canadian poultry industry now, and it is always evolving. This is a race. We always need to be on top of it because if not, it will start winning us. Complete diagnosis requires histology, bacteriology, molecular diagnosis, and isolation for a proper and successful autogenous vaccine program. Vaccination of breeders reduces the disease severity but does not prevent infection. That's the reason we need constant monitoring on how effective is the program. Some avian reovirus may react different to ELISA, which makes serological monitoring difficult. Other techniques like virus neutralization need to be correlated with genotyping and used more often. The selection of candidates for autogenous vaccine manufacturing it's really important. You need to communicate your real suspected flocks with the vet team, with your vet team, for timely and accurate autogenous vaccine program design. We want to get the right rears. It can take up to 2 years to have a program fully implemented. It is important to have the proper field isolation. With that, I would like to acknowledge Dr. Karim's lab, my advisor in my PhD program, my PhD committee, Dr. Faisal Karim, Fran van der Meer, Dr. Holly Sellers, and Darko Mitevsky, the Institute for Applied Protein Technologies, the Animal Health Laboratory in Ontario, Dr. Marina Brash and Emily Martin, the Animal Health Center in BC, Dr. Victoria Baus, the University of Calgary, Faculty of Veterinary Medicine, and the University of Georgia, College of Veterinary Medicine. Funding support during my PhD, the Agricultural Funding Consortium, MITAX, and the Institute for Applied Protein Technologies, and finally, Poultry Health. Thank you very much. I am open for questions.
Well, thank you, Dr. Victor of Poultry Health Services. We've got lots of questions that have come in already, so let's take a look at them. First in from Nancy, why doesn't Rio affect broiler breeders?
That's a very good question. We think that it's because they are affected later in life. There is something in poultry that we are calling clean barn syndrome, and that is that now we are more efficient cleaning our houses and doing our cleaning and disinfection. But still, there is some virus that is still viable in the farm. There are good presentations and papers by Dr. Hoyer, if the person asking it's curious about it, and he mentioned the importance of Aphytobius diaperinus, that little pest in our farms, holding some viruses, some nasty viruses from cycle to cycle, right? So you grab some of those pests, and you smash them down, you can find from Gumboro, CAD, fall adenovirus. So we are thinking that is one of the ways some of these diseases perpetuated. So some of the things is that there are always some pieces of material that don't get very well disinfected, and that means that the birds are challenged afterwards, after that particular age-dependent time in which those birds can get the disease, right? So they will get infected, but they will not be exhibiting the disease. By getting infected later in life, that is close to lay, for instance, they will be able to shed the virus to the offspring, causing the disease in the offspring, in the broilers. Yes, that's more or less what I have for that.
And so would it then build up? Like if it's something, if you don't be careful with the intensity of the virus or the occurrence of it within your facilities, could really sort of be amplified?
Yes, it definitely gets amplified later. That's where the importance of having the autogenous vaccine, a good autogenous vaccine program comes in place, right? So that you prevent that particular shedding to the offspring happening, right? The way that.
All right, another question has come in. It says, or rather, with maternal antibodies for Rio in broilers lasting for a maximum of 10 days, would a hatchery spray vaccination for Rio be recommendable, or could it interfere with the maternal antibodies?
Okay, so there is something very important to keep in mind here, and that is, fortunately, there are no live variant reovirus vaccines right now in the market. There are only classic vaccines. And within the classic vaccines, there are just few of them that are able to not interfere with Marek disease vaccination, for instance. So you're limited in how many types of vaccine viruses you can use. So because you have only classic live viruses for that, the immunity that you will be able to generate will be against that classic challenge. And these new viruses that are causing these high numbers in viral arthritis, they are variants. So the vaccination for classic vaccine wouldn't do anything to this challenge, to this variant challenge. So just for you to understand, from the point of view of the immune system of the bird, these two variants are as different as a bronchitis can be from a Newcastle. Your immunity will not cross protect in this case, on the case of these variants, right? You perhaps could expect some degree of cross protection within same clusters, but definitely not between a cluster 2 or cluster 3, for instance.
So is there work being done on vaccines for some of these variants, or are there just too many of them to start tackling?
That's a good question. So far, I know that there are efforts by the University of Georgia producing a live cluster 5 vaccine. I think that's going to help the industry a lot, because we do need a live prime for variants. And fortunately, in the case of the cluster 5, this cluster has not changed much and is pretty well distributed. It represents a good percentage of the challenge that we observe. So I think that will help the industry. But you are right. There are so many right now. And what we expect to happen in the future is that when you start controlling for particular clusters, then what's going to happen is that will signify an evolutionary benefit for a cluster that is not between that particular, or not controlled by that particular program. Therefore, in other words, if you start controlling by 4 and 5, don't get surprised if the next year or so you start having problems with a different cluster, right? And then you have to generate an autogenous vaccine strategy for that particular virus and so forth. That's the reason we need to be constantly monitoring, because it takes so much time to implement everything in our systems.
It's frustrating how they can always keep one step ahead of us and catching them.
Yeah, it's a whack-a-mole game. It's and if you think about this, that's the same thing happening with COVID as well, right? So variants are appearing as well.
Mm-hmm. All right, another question that's come in, again, thanking you for the excellent presentation, a couple of those comments, but is there cross protection between variants? Do the existing Rio vaccines eliminate the carrier stage? So a couple of different questions there.
So I doubt, so far I haven't seen any information about reovirus vaccines able to eliminate the carrier stage. I know that these are different viruses, like for instance, the case of Marek disease vaccine, right? Or Marek disease biology, right? But once it is inside a bird, I would doubt that you would be able to eliminate the carrier state. That's one thing. In the case of the cross protection, perhaps I can show some information here. Let me see. So if I can share the screen, perhaps I can show something here. Well, it's disabled. So the thing is that you are expected to find certain degree of cross protection between, let's say, a cluster, because you have clusters 1, 2, 3, 4, 5, 6, 7, and within those clusters you sometimes have subclusters, right? And sometimes if these subclusters are kind of close, you should expect to have certain degree of cross protection, but sometimes they are just far away, and we can kind of I wouldn't say predict, but perhaps expect certain cross protection if there is not so much difference. There is some work done in bronchitis in which they found that if two viruses are far away by 5%, you should expect certain degree of cross protection. That is 95% similarity. And we believe that cross protection should be kind of waning up to the point in which they reach 90%. So it's difficult to say. You have to actually have birds and test them. You can expect certain degree of cross protection between 90 to 95%. But that's again in vitro, right? So you should expect perhaps no cross protection at all below 80%. I would say similarity between proteins.
So the best strategy is to try and do prevention, although it sort of seems something that's pervasive and that it's kind of always lying there and underground and ready to jump up if we're not careful.
Yes. We need to be constantly monitoring our cases just to see how these variants are changing, so that we can tailor our control strategies to minimize the damage caused. Right. That's as much as we can do. We are limited by the technology we're having currently.